Okay, this is Mrs. Tole from Emerald Private Tutors. So today we are looking at quadrilaterals. Okay, now when we are looking at quadrilaterals, what you need to remember with quadrilaterals, you must know that sum of interior angles. So sum of interior angles. So quadrilaterals have got from quad 4 sides. We've got 4 sides. So we are saying sum of interior angles. We are saying A, B, C, D. A plus B plus C plus D must give us 360. So sum of interior angles of quadrilateral must give us 360. You must always remember that. Now, then we move on to different quadrilaterals. We've got trapezium, we've got kite, and we also look into parallelograms. Now, trapezium, we've got one pair of opposite side, which are parallel. So these two are parallel, and you must always remember that. So one pair of opposite side is actually parallel. And how would we get our area? We get our area by saying half AB, which is your A, and B, the parallel sides, times your height. And your height, remember, you need to calculate the actual height of your your trapezium, because these sides are not actually perpendicular to the base. Now, let's move on to kite. Okay, now kite, with kite now, it's a different story now, because what we have, we've got adjacent sides. Adjacent sides, this is what we call adjacent sides that are equal. Adjacent sides are equal. You can see that these two are equal, and also the long diagonal, the big diagonal, long diagonal bisect the short diagonal. The long diagonal bisect the short diagonals. Then also another thing that I need idea is that the big angle here, these two angles, they are actually equal. These angles are equal. Okay, these opposite angle, one pair of opposite angles are equal. So one pair of opposite angles are equal. One pair of opposite angles are equal. These big angles, okay? These ones are the ones that are equal. These ones are not actually equal. But remember, you add up all of them, interior angles, you get 360. So you must know that B is equals to D. So we're saying diagonals cut perpendicular, meaning to say they form a 90 degrees here. They are perpendicular to each other, and like long diagonal bisect, short diagonal, also opposite angles, and also these angles, they are bisected here. They are bisected. So this bisected, long diagonal bisect these to these angles here. They are bisected, and also area of the kite, meaning to say this area here, this part here, and this part here are actually equal. So the area of a kite is AB, which is the long diagonal times the short diagonal over 2. That's how you get the area of the kite. Okay, now let's move on to parallelograms. Now we've got different types of parallelograms, and we must know that the properties of parallelograms. So the three parallelograms that we'll be working with are rectangle, square, and rhombus. So what are the properties of a general parallelogram? Is that both pair of opposite sides, they are actually equal, meaning to say here we are saying these two sides, the opposite sides, the AB is equal to DC, and also AD is equals to BC. Now that's what we are saying here. Then both pair of opposite angles are equal, meaning to say this angle here and this angle, they are equal, and this angle here and this angle here are actually equal. Then diagonals bisect one another, meaning to say each diagonal cut the other diagonal into half. So this side is equal to this side, and this side is equal to this side. Okay, then area of all parallelogram, is base times height. So you must have a base and you must have a height, then you can get your your area. Now 5 properties of parallelograms, you need to prove one of them. So if you are to be asked that prove it's a parallelogram in general, you need to prove one of these 5 properties. Okay, one of these 5 properties. Don't prove all of them. So it's either, depending on the given information, you can prove that both pair of opposite sides are parallel. And how do you get that? What do you use to get this? You look at what is it? You look at properties like parallel lines. You look at a gradient, equal gradient equal. Then you look at what called type of angle like alternate angle. Then you look at what called corresponding angle. Then also you look at co-interior angles. So if you find these co-interior angles, they must be adding up to they must add up to to 180. So if you find that this side, you find one of these properties on your on lines of that shape, particular shape. You find that in the shape, because remember these shapes, when they are coming, you find them inside a circle, you find them inside another big shape. So you need actually to look into the values that are given, because remember you use this in in analytical geometry. You apply it in analytical geometry, you also apply it in Euclidean geometry. So you need to understand very well that how do you now prove that opposite sides are parallel? You use your gradient, you use alternate angles if they apply, you need corresponding angles if they apply, co-interior angles if it applies. Then you can tell now those lines are actually parallel. Now let's also look into another point, is that both pair of opposite sides, this just means that it's the same as above. Both pairs of opposite sides are equal. Now what do you use here? You use the distance. Now you are going to calculate the distance to see if the sides are actually equal. Then also opposite angles, both pairs of opposite angles are equal. Both pairs of opposite angles are equal. Then the other thing is that diagonals bisect one another. Then the last one is that one pair of opposite sides are both equal and parallel. Here is the thing here. You can be given information for one pair of sides. The other sides are not given. So what do you do now? You work with one side, one parallel. So it means that you can just, from this, you can just prove that AB, you can prove that AB is both equal, it's parallel and actually equal to DC. That's what we mean by this. So you need to prove one of the sides to see that is it parallel, are they equal as well, without looking into AD and BC. So because sometimes you're given much information for two opposite sides only. Okay, let's move on to another to individual parallelograms, where you need to prove that is the shape or the quadrilateral is a rectangle. Now, how do you prove that? You prove that by saying, you know what, one angle should be 90. One angle should be 90, and also diagonals should be equal. Diagonals should be equal, meaning to say, if we are to say A, B, C, D, we are saying AD must be equal to BC. That's what we are saying here. Diagonals should be actually equal for a rectangle. Then area is length times width, which is your your base times your height. Remember what we said, just a base and your height, and this one is just your length times width in times breadth. There's no problem about that one. Then we move on to a rectangle. Sorry, rhombus. Now a rhombus now we have got a rhombus. It's a square which is more like twisted. Okay. Then what we have with the rhombus, we see that with the rhombus, adjacent sides, they are equal. Adjacent side, remember, it's just a square that is twisted. So you find that these all sides here, they are equal. All the sides are equal. So you're saying adjacent. If we can prove that the adjacent sides, they are equal, then we know that we are dealing with with a rhombus. Then diagonals bisect at right angle. Diagonals bisect at right angle. These diagonals, they didn't bisect at right angle for rectangle, but for rhombus, they bisect at 90 degrees, which means they are perpendicular to each other. Now, diagonals bisect angles of a rhombus. Diagonals bisect angles of the rhombus. So these angles here are bisected These angles are bisected. That's what it means. Then diagonals bisect area of the rhombus, meaning to say this area here of this side here and this area here, they are actually, it's actually equal. Then let's move on to the last one. Is what is it? Is the area here is base times what? Times height. And you must know how you get your height. Sorry, here. You must know how you get your height here. This is your height. Because remember, it's not straight. It's not straight. So you need to find a height here. The height here that is straight are going to the perpendicular to the base. Now let's move on to the last one, which is a square. Now a square is applying all the properties of a rectangle, a rhombus, collecting the parallelogram, because the one is a parallelogram, and now also the kite. So you find that it combines a lot of what is it, a property. So if you ask to prove that it's a square, please, you just need to prove any of these things, and there are many to prove. Adjacent sides, they are equal. These sides, all the sides are equal. So adjacent sides, these are what we call adjacent sides. They are equal. Then we move on to one angle is 90 degrees. Then once you're able to prove that the interior angle, one of the interior angles is 90, then you're fine. Then diagonals are also perpendicular. Diagonals are perpendicular. They cut vertical at 90. Then diagonals are equal. You see it's taking property of what is of a rectangle. Then also diagonals bisect angles in the area of the square. So diagonals are again bisect. So it's combining the characteristics or the properties of rectangle, of rhombus, and also of a kite. Okay. So this is the end of the lecture. We'll look into questions later after doing what is it, after having what goes looking into second geometry. Then we can work with these questions together. Okay. Thank you so much.